All right, so today we start our lesson on linear functions, part 2. Okay, part 2. Yes, linear functions, part 2. Okay, so basically everything, when it comes to linear equations, our ultimate goal is to get to this right here. Y equals mx plus b, where I have a slope and I have a y-intercept. That's our ultimate goal in linear equations because, I mean, that's just how you write linear equations. Now, there are different times and situations where you have things, but you don't have others. And you have different situations where you're like, okay, well, I have a point, I have a slope. How on earth can I go with just a point and just a slope and draw create a linear equation from that? Well, that's a really good question, and I'm glad y'all asked it, okay, and not me just saying it. I'm glad y'all asked it because y'all are so inquisitive, okay? We use what's called, because mathematicians are very brilliant when it comes to naming things, if you're given a point and you're given slope, we use a formula called point slope. Brilliant naming, okay? Brilliant naming. Now, what point slope formula is y minus y1, oh, we've seen that before, y1, we know where that comes from, ordered pairs, okay, equals m, who remembers what m equals? Slope, good, all you had to do is read up here and you saw that it equaled slope, times, oh, there's parentheses, x minus your x1, oh, we've seen x1 before, when we label ordered pairs. Now, our ultimate goal, again, is to get to what?
Y.
Y equals mx plus b. Get y by itself, okay? Now, this is a situation when you're given a point on a graph and you're given the slope. You don't have a graph in front of you, but you're given a point and you're given your slope. And you have to somehow create an equation from those two things. Well, I'm just so glad there were some mathematicians in the old days that figured out a way to make it happen. Okay? So, our goal is to make it happen, Captain. All right? Anytime you are given an ordered pair, doesn't matter if you have 1, 2, 3, or 4 of them. Anytime you're given an ordered pair, what does Coach Kimball want you to do? Label. Thank you. Label first. That is x and y1. We will always label because it's the first ordered pair that I'm given. Step 1 is to label your givens. Now, what is a given? It's whatever's given to you. How about that? Boom. Okay? Try to trick you. Now, this says slope equals 2. Okay? What is slope? What is slope? What's the term we use for slope? M. So I must now label, because that didn't label slope. Technically, that just said slope is. Slope is 2. Well, I want to know what is that label term. It's M. So step 1, label your givens. Okay, remember, givens is what you are provided by the problem. It's not a pigeon. Okay? There are gibbons out in the world, but we're talking about givens. Step 2 is Coach Kimball's favorite mathematical principle of all time in algebra, because you literally use it every single unit. Substitute. Ciao. So the formula we have, just because every time I scoot the paper up we don't see it anymore, but it is y minus y1 equals m times x minus x1. Now, you don't have to have this formula memorized. I do, because I teach it. But it is on your star chart. Okay? I believe it is on your star chart. Yep, there it is on the star chart. Point slope form. Boom. There it is. Ka-chow. Okay? So let's substitute. I have y1, there's a y1, x1, there's an x1, there's an m, there's an m. Substitute everything that you have. So we have y minus, what is the value of my y1? 1 equals, what is m? 2. What is the value of my x1? Now, is 1 negative? Is it negative 1 originally? No. Why do we have y minus 1? Because the formula tells me I have to subtract. Know the difference. Okay? Now, when it comes down to it, the whole goal is to get y by itself. How do we do that? If only there was something on Coach Kimball's board that told us what to do. Distribute first! Yes! Bing, bang, boom. Distribute first. Get rid of those parentheses. The parenthesi. So I distribute. When you distribute, what operation is actually happening? Multiplying, thank you. 2 times x is 2x. 2 times negative 4 is negative 8. Now again, my whole goal is to get y by itself. I want to move this negative 1 over here. How do I move a negative 1? Add 1. Now, am I going to add 1 to the 2x or to the negative 8?
Negative 8.
Why?
2x.
Oh, you started out so confident and then you questioned it. Why am I adding to the negative 8 and not the 2x?
It doesn't have a variable.
Because this doesn't have a variable with it. Remember, when you move stuff, you combine it with its like term. Okay? So this gives me a 0 pair, aka cancels out. So now I have y equals... Isn't that my goal? To get y by itself? Isn't it by itself?
Yeah.
Then I have 2x because nothing combined with it. Negative 8 plus 1, though, is... Negative 7. Now, again, the ultimate goal is to get to what?
Y. By itself.
Y equals mx plus b. Y, or y by itself. All of them are synonym descriptions. Okay? Do I have y by itself?
Yes.
Do I have y equals?
Yes.
Do I have y equals mx plus b? Ka-chow. Oh, I forgot step 3. Forgot to write that down. Solve.
That's it.
That's it.
That's all
Sorry.
for today?
I went down the wrong pipe.
Is this all for
Basically. We still got 2 more pages of the notes, though. What? What? Let's do another one. Just for funs. For funsies.
Do we do one that has a
Okay, we're actually going to do number 4 here, which has a fraction. Okay, but it also has what in it?
negative?
Negatives. Okay, step 1 is to label your givens. Same thing. Label your givens, which you're given ordered pairs, x and y1, always, now, and forever. Anytime you have an ordered pair, label it x and y1. If you have a second ordered pair, that's x and y2. Okay. Your slope is negative 3/4. Okay. Now, x and y1 are also both what? Negative. So let's see how this adjusts our equations. All right. So same thing. We substitute. Now, the formula tells me to subtract. Now, this is supposed to be y minus y1. What is the value of y1? Negative 1. So I'm going to put a negative 1 there. Equals my slope, negative 3/4. Then x. The formula tells me I have to have subtraction. Then I substitute the value of x1 and I get negative 8. Okay. Now we simplify. However, before we start distributing, let's make some adjustments to our formula. Because I have minus a negative, what is subtracting a negative the same as? Adding a positive. Slash and dash. slash and dash. Okay? Now that I have eased my concerns and got rid of those nasty minus negatives, yeah, okay? Everyone likes adding anyway. What do we do first? Distribute. Okay, get rid of the parenthesi. Y plus 1. Dyslexia, don't leave me alone. Negative 3/4 x. Negative 3/4 times 8. Now, before you just shout out an answer, also, I already know it by memory, okay? But before you shout out an answer, let's just do it in the calculator so we remember how to do this in the calculator. How do I write a fraction in the calculator?
Alpha x equals x.
Okay, alpha x. These two buttons right here. Now, before I do the alpha x, my fraction is what? Negative. So I'm going to hit negative alpha x and then type in 3/4. I hit the right directional pad. And then what operation is happening in distribution?
Adding.
Oh. Multiplying happens in distribution. Thank you, Jordan. Okay, so times 8. Then we hit enter and I get negative 6. All right. That's just a reminder of how to put a fraction into the La Calculadora. Okay. Now, our ultimate goal in life is to do what? Solve what?
Equations.
My problems. Solve my problems. That is true. Number 4 is currently my problem. All right, and I need to solve it. What are we trying to do when we solve, though? Starts with an I, rhymes with olate the variable. Isolate the variable. Okay, so how do I move this over?
You multiply.
Oh. I subtract. To move something, you add or subtract.
Subtract 1.
And so now I have y equals... Isn't that the goal? Negative 3/4 x.
Negative 5.
Aww.
4.
I appreciate you trying.
7. Negative 7.
Negative 7. I have a negative, and I'm taking away more negatives from the original, so I have negative 7. Okay, I have negative 6, and I subtract one more, I get negative... Oh, you can't even see what I'm typing. Then I have negative 7. Okay? You know what's great, being in 9th grade, is that you can use a calculator.
Well, you can use a calculator in the 9th grade.
Yeah,
So you can't?
you can.
Oh, you can't.
But starting in, like, 9th grade, you really get to use it.
I don't know how to use a calculator when I was 10. I don't know.
Like, we weren't allowed to at all.
Pictures of it.
I like to have it for like the last couple of minutes of the test.
Interesting. I would like y'all to try número 5. Por favor.
You say it in this
I would like you to try número 5. Por favor.
Oh, 5.
Try number 5, please. Por favor. Please. It helps to know Spanish.
Why did you put the 1 there?
Why did we put the 1 where? Because this right here, if you look, that's a negative 1. So I put y minus negative 1. But because I'm subtracting a negative, it changes to a positive. I put the 1 there because that's what the original formula. The original formula is y minus y1. Well, that's what I labeled as y1, was that negative 1. So that's why it goes there. Okay. Which is also why the x1 goes in that little parentheses, because that's what the formula says. While y'all are doing that, I should probably take attendance. 1, 2, 3, 4, 5, 6. All right, I feel like that is a sufficient amount of time. And now it's time for
I'm not ready.
the wheel of not ideal. Because it's not, y'all don't like to go up there and show your work. That's why it's called the wheel of not ideal. So here we go. 3, 2, 1, spin your life away. Alexa. Sorry? How far have you gotten? Cool. We can actually finish it all together as a class on the board. Yeah, go up there and we can work on it as a group. Go ahead and do everything that you've done so far, and then we can talk about the rest. Before we continue, when you substituted that 4 in, is x1 positive or negative? Positive, so it should just be x minus 4. There you go. Sweet. And then negative times a negative is a... Boom. Oh, hold on. Okay, so now on the y side, Alexa, you have y minus negative 3, right? Okay, so when you subtract the negative, what is that the same as? Adding a positive, right? So what we would rather do is change the y minus negative 3 into y plus 3. Okay, and now instead of adding, you will do what? Perfect. There you go. And so now we get y equals... plus 1. If it was 3 minus 4, it would give you the negative 1. 4 minus 3 gives you positive 1. Perfect. Go ahead and box it up. And that's our right answer. Awesome. See, that wasn't too bad. Okay. Attempt number 2. Número 6. Number 6.
Wait.
6.
Oh.
1, 2, 3, 4, 5, 6.
I use my hands to count.
There's nothing wrong with that. You can use your hand to count or to multiply by 9. What is 9 times 5? So I have 1, 2, 3, 4, 5. Hold it down. What number do you see? 45. Yeah. What's 9 times 6? 1, 2, 3, 4, 5, 6. Ah. It's like magic. I sure hope Ben doesn't get picked. Someone wake him up. Ben, we're already done with notes. You missed it all. Missed everything. Just kidding. But you did miss a lot. How's it going, Connor? Any questions? Okay. All right, time to spin the wheel of not ideal. Jordan! Nice. Labeling. Perfect. Great. Awesome. What? For my advisories. The advisory tutorials. Is that your final answer? How do I know? Ah. That is correct. Okay, that is the correct answer. Now, what she did is she just automatically changed this to y plus 9 because she noticed that it was negative. So she knew she would have minus a negative 9, so she just made it plus. Minus 0, when you distribute, 4 times 0 is 0, so you don't really need anything over there. Then when you subtract 9 to both sides, there's nothing to subtract 9 to, so you just put it down right there. So you have y equals 4x minus 9. Corbin, can you go erase the board for me, please? Thank you. Now we're on to the tables. Yeah, wahoo. Good old, can go Mario Yahoo. Yahoo! Alright. Writing equations from a table. Now, there are 2 total ways to write an equation from a table. The first way is to write it in point slope. Okay, the other way you can write an equation from a table is using slope-intercept. Okay, 2 different ways that you can extrapolate information from a table. Okay. Now, in order to do slope-intercept form, you need slope and you need a y-intercept. In order to get the y-intercept, okay, what must equal 0?
The slope.
The x value. So when you look at a table, you look at the x values. Now, example number 1. Do any of these equal 0 on my x part? Do I have any 0 in my x side of the table? No, which tells me that I'm going to use point slope formula. Okay, I'm going to use point slope formula because there is no 0. We'll get there. We'll get there. Okay, so in order to do point slope, I need 2 things. I need a point and a slope. Now, there is a certain way to get slope from a table, And that's when I do m equals delta y over delta x. Who can remind us what the triangle Greek alphabet letter delta stands for? Change in. Just means change in. The change in y over the change in x. It's actually still on the board right in the middle over there. Okay? Change in y over the change in x. Now, to go from 12 to 14, this y value changed by doing what? Adding 2. So, I put positive 2 in the numerator. And in the denominator, to go from 3 to 4, what did we change by? Plus 1. Hopefully you add 1 to go from 3 to 4 and not minus. Okay? Which gives me 2 over 1. Now what does 2 over 1 simplify to? 2. So I have my m. What else do I need for point slope form? I need a point. A point is an ordered pair. Okay? Now, in this table, I have 1, 2, 3, 4, 5 different points in the table. And you can pick any one of them to use. Looking at these numbers, which point would you rather use? 312. That's what I heard first. Okay, so that is my x1 and that is my y1. I heard 312 first. So my point is 3, 12. That's the point we're going to use. Point slope formula. I'm going to rewrite it to remind us. It's y minus y1 equals slope times x minus x1. So I have slope. I have a point. Now what do we do? Coach Kimball's favorite mathematical principle? Substitute. Okay? So I have y minus, what's the value of my y1? 12. Slope was 2. What's the value of x1? 3. Now, does that look clean? AKA, there's no minus negatives? Yes, it looks clean. There's no minus negatives, so I can now go ahead and distribute. Y minus 12 equals 2x minus 6, thank you. Now our whole goal in life is to solve what? For y. I need to get y by itself. How do I move something over? I add. Perfect. Now why do I not add the 12 to the 2x? Because 12 doesn't have the variable x. So now I have y equals 2x. What is negative 6 plus 12?
6.
Positive 6. If you don't believe me, plug it into your calculator. Yes.
Is it only the x minus?
Is it always going to be minus? I wonder. Now Isa's going to ask us, well, what if there is a 0 in the table? Hey, look, example number 2. Is there a 0 in the table? Yes. If there's a 0 in the table, I can now use slope-intercept form, where I need two things, the slope and the intercept. The intercept is when x equals 0, the b value is the y. X equals 0, what's my y value? Negative 4. Ha! Nice. Okay? Slope doesn't change. I'm trying to get slope from table, so I have to find the change. To go from negative 4 to negative 3, what do? Add 1. So I have positive 1 on top. To go from 0 to 2, what do? Add 2. So that plus means positive there. I now have slope. I have y-intercept. I can now write y equals 1/2 x minus 4 because my y-intercept is negative. Nice. Questions, comments, concerns? Are we good on this side of the room? Over here? They want group that's directly in front of me? I'm getting a lot of answers from over here, not a lot of answers from over here. For like 2 people. And 3 people, because Alexa had to go up to the board. All right. Let's do one more example before going on to the last page of notes. All right, let's look at number 4. Okay, look at number 4. We will do this one together. Okay, I won't have y'all do it and then go up to the board. We'll do it together. First things first, I'm the realist. Anyone get the reference? No? Oh, okay. I'm just going to hide in my corner now. All right. We need to figure out if I have 0 in my table on the x side. Do I have 0 in my table on the x's? No. So when I see that there is no 0, what does that tell me that I need to use? I'm going to use point slope. I'm abbreviating here. PS, point slope. Okay, which means I need 2 things. I need a slope and I need a point. Okay, there's no 0, so there's no y-intercept. Yes. Okay, so my slope, first and foremost, change in y over the change in x. Okay, to go from -4 to -6, we are subtracting 2. To go from 6 to 12, we are adding 6. So that's -2 over +6. Can that simplify? Yes, to negative
1/3.
-1/3. Thank you very much. They're both divisible by 2. Now, remember the point, we have 5 options here. We can use any of them, but we only need to use one of them. Okay, but we can choose whichever one. Which one would you like me to use?
12 negative
6 negative 4.
12 negative 6.
I heard 2 people say 6 -4. So
Yay!
6, -4 is the point we are using. So that is my x1, that is my y1. I have m, I have x and y1. I have my formula of y minus y1 equals m times x minus x1. Whoops. So I have my labels. I've labeled the givens. Okay. We now do the best and most awesomest mathematical principle there is. Substitute. So I have y minus, what is the value of my y1? -4. What is the value of my slope? What is the value of my x1? Sweet. Okay. Now, is this clean?
Yes.
No. Why is it not clean? Because I have a minus a negative. So what do I need to do to it? Make it a positive and add it. Slash and dash. Okay. Once we have cleaned it up, we can now do what? Starts with the letter D, rhymes with distribute. Distribute.
You just said it.
That's the point. I've literally been doing that all year. Okay, so I'm going to write it over here so I have room. Y plus 4 equals -1/3 x. Who can tell me what -1/3 times -6 is? +2. Okay, so just to remind ourselves how to type it into the calculator, because it's just nice to see that reminder. So I have negative alpha x to give me my fraction of 1/3. Okay, and then I times by 6. Sorry. Times -6. There we go. Hit enter, and I get 2. Now, my whole goal in life is to solve my problems. And currently my problem is the fact that y isn't by itself. So how do I solve said problem? Subtract 4. To where now y equals negative 1/3 x. 2 minus 4 is negative 2. Yes. All right. So what she's saying is if I know I am adding 6 to go to the next value here, I can actually artificially create my x equals 0 by working in the opposite direction and subtracting 6. 6 minus 6 gives you your 0 right there. And then if I work in the opposite that way, if I add 2, negative 4 plus 2 gives you negative 2. So my y-intercept is negative 2. My slope is negative 1/3. For some people. Some people have a hard time understanding working in the reverse. But that's totally an option, and I'm not going to tell you not to do that. If you understand it, then do it. Because that's 100% correct. Okay? Turn the page. All right. Identifying the slope and a point from the point slope formula. So we're working in the reverse. We have been given a slope and we've been given a point and we've been substituting it in. Now we're going to unsub. Okay? Now we're going to unsub. So, step 1. Label your givens. Okay? So what am I given here? Y minus 6. Well, that 6 is my y1. Negative 2/3 is my m. And then x minus 3, the 3 is my x1. Step 2. Unsub. Because we're going from the formula to the slope and point. We're working in the reverse now. All right, slope is easy to unsub. It's literally the number you're given. So negative 2/3 is your slope. Okay. What's difficult for people to understand is my point. When I take my point out of the equation. Okay. My point in this one is actually going to be positive 3, comma, positive 6. Okay. Now you're probably like, Coach Kimball, it says y minus 6. And x minus 3. Yeah, I know that. However, the formula tells me what? You have to subtract. Okay? The formula says I have to subtract these. So I'm not saying that that is negative 6. I'm saying the formula has to subtract. So I'm subtracting the value of y1. And what is the value of y1? 6. Positive. Now, graphing it is actually really easy. I give you a point on the graph. 3, comma 6. Well, I'm going to go to it. 3, comma 1, 2, 3, 4, 5, 6. Boom. There's my 3, comma 6. and I'm actually going to follow my slope from that point. So that's down 2 over 3. I can work in the reverse and go up 2 left 3. Now, when we are putting a linear equation onto a graph, once we have our points, what do we do with the dots? You connect them. You make it continuous. It is not an inequality, so there is no dash or solid. It's automatic solid because of the equal sign in the equation. Let's do another one. Step 1 is label your what? Label your givens. Slope is m, and m is 3. That was easy. Okay. Now my point, okay, right here, x minus 4. Remember, the formula tells you that you have to subtract. So what is the value of that x1? Positive 4. Now here's where you need to make sure you understand the concept. This says y plus 3. The original formula says y minus y1. What is the only way to change this minus to this plus? Is if 3 was negative. That's the only way. So when I pull it out, I'm going to make sure I say, hey, the only way that that's a plus is if that 3 was a negative to begin with. Sorry? All right, so now I need to graph it. I'm going to go to my point. 4, 1, 2, 3, 4, negative 3. Boom, there's my point. Okay, now I use the slope in order to graph it. However, I have a whole number for my slope, but I need a rise and a run. So I put whole numbers over 1. So that means I'm going to have a rise of 3 and a run of 1. Rise of 3, run of 1. I can also go in the reverse. Down 3, left 1. Now, what's the minimum amount of dots that you could have? 3. 3 is usually a good number to have. Okay? And then I can connect them. Yay! You said it's easy? Good.